Hey guys, what's up everybody? Welcome and welcome back to the Apex Academy of Mathematics, where learning the language of the universe begins here. Alright guys, and in today's video we're just going to be doing a paper that I had created for my students for the end of term mathematics exam 2021. This paper was just created based on the amount of topics that were done throughout the period of September through to December of the year 2021. This video obviously is just geared towards helping these set of students to understand some of the concepts that they might have missed and some of the concepts that they might have misunderstood throughout that term. But of course this video could definitely benefit other students out there who might have done the topics that we're going to be discussing in this video. Alright, I know that I have not been posting a lot. Well, I haven't been posting at all, but I promise you, going into the year 2022, you're going to be seeing a lot more videos like this, along with more face-to-face videos with me on the board teaching you a lot more math concepts. All right, I am so sorry that I've been missing in actions for so long, but I have been putting in place plans to make content more beneficial to you on a wider scale, not only for CSEC students but for students doing EDXL exams, GCE, SAT, CAPE, and just math in general. So we're definitely going to be turning up the game a little bit more for the year 2022. So again, I do apologize for missing in action, but you can definitely reach out to me on my Instagram at Apex Academy of Mathematics. You can reach out to me on my Facebook page at Aki Math Peert Wiz. And of course, if you look in the description box below, you can get my WhatsApp contact if you need any assistance as it relates to math in general, wherever you are in this world. All right, but let's just get into the video. Again, I'm so sorry that this is how I'm going to be starting the return to my channel. But like I said guys, coming 2022, this is my first video in the past 6 or 7 months, and this will be my final video for the year 2022. So there's going to be a lot of improvement which you're going to be seeing starting in January. So with that said and out of the way, thank you guys for watching, and I hope that this video is going to be beneficial to you. So let's get into it right now. Right, so basically the rules for an exam is usually the same. Answer all questions, use useful formulas are always placed at the back of every exam paper to assist students, ensure all workings are shown where necessary. Even with the use of a calculator, you ought to show working. All right, so let's just get into it here guys. And now for question 1 here, we are starting with a fraction question, and it says here that all steps in your calculation must be shown clearly. Calculate the value of 3 2/5 minus 2 7/8 in bracket divided by 1 2/5. And so clearly in this question we have to apply the principles of PEMDAS, or what some of you guys know as BOMDAS, where we work out what is in the bracket first, followed by whatever else comes after. So usually we divide before we subtract, but because the parentheses or the brackets are there, we obviously gonna have to work out what is in the bracket followed by the division. All right, so just gonna go to a second page here. This is 3 2/5 minus 2 7/8. Let's go over here. So this is 3 2/5 minus, let's get back here again a second guys, 2 7/8, 2 7/8, and that's going to be divided by 1 2/5. So put in bracket here, that's going to be 1, that's divided by 1 2/5. I think I may have to copy and paste if I have to keep rewriting like this. All right, so here we go, guys. So first thing we're gonna do is just convert all the mixed fractions here to an improper fraction. So we say 5 threes is 15, 5 times 3 is 15, plus 2 is 17 over 5, minus 8 twos is 16, 16 plus 7 is 23 over 8. Okay, pardon me, that is over 8. And then we can divide here by convert 5 ones 5 and 2 is 7 over 5. I'm going to place this back in the parenthesis, and because inside the parenthesis we are subtracting, we are to find the LCM. Okay, so we draw a line here, find the LCM. The easiest way to finding the LCM is to multiply the denominators. So that's 5 times 8 is 40. So the LCM here is 40, and we divide 5 into 40. That should give us 8 times. We should multiply the numerator by 8. And 8 into 40 goes 5 times. We multiply the 23 by 5. So 8 times 17, that should give us a total, I believe, of 136. Alright, so that's 8 times 10, that's 80. And 8 times 7 is 56. So that's 136, that is correct. I'm going to subtract here. 5 times 23, that looks to be 115. Okay, all right, so if we subtract this here, we should get basically 21 over 40. Okay, and then we just proceed now to divide by 7 over 5. According to the division principle, then we know that we are going to change the division sign to multiplication. We're going to keep the first fraction, which is 21 over 40. And we're going to reciprocate the final fraction, that's 5 over 7. So with that said, then 7 into itself one time, and 7 goes into 21 3, and 5 into itself one time, and 5 into 48. So our final answer for this question is 3 over 8. All right, so hopefully you guys got that very simple fraction there. We're just going to go back now and work on question 2. So that's 4 easy marks for you there, guys. All right, so we're going to work out part B here that talks about the simple interest on $12,000 is invested at 4.5% per annum is $1,620. We are to calculate the period of investment. All right, so this is a consumer arithmetic question, and we're looking for the period of investment. And we are told what the simple interest is. Well, we are told that the simple interest on $12,000 invested at 4.5% per annum is $1,620. Now, this sort of question confuses a lot of students, all right? Because sometimes, usually what most students will do, they'll think that the number, the value that comes after simple interest usually is the simple interest. Okay, they're saying that the simple interest on $12,000, which means that the $12,000 is your principal. It is what you invested. But it said it here, right here, that $12,000 invested at 4.5% per annum is $1,620. So just be careful when you're reading the information here. The $12,000 is your P. The 1,620 is your SI, or just your I. Okay, we call it simple interest. Some persons just call it interest. And the 4.5% is your R. And you're looking for period of investment, which is your time. So you're looking for T. Right? So the formula that you'd naturally use for this here is that interest, or simple interest, is equal to the principal multiplied by the time, multiplied by the rate, divided by 100. And what we could do is just plug in the values that we know, and we could plug in the values that we know and then transpose to make T the subject. But there's also an easier formula where we have a formula for time, or period. Time is equal to the simple interest multiplied by 100 divided by the variables that are left, which is your principal, times your rate. So I'm sure that most of my students are aware of this formula here, but a lot of students are also using the simple interest formula and doing their transposition. Either method is fine. Okay, so based on the question before, they said that the interest that was received on the $12,000 was 1620 multiplied by 100, and we're going to divide that by the principal to which you got the 1620 on was 12,000, and we're going to multiply that by the rate, which is 4.5%. I'm definitely going to have to grab my calculator here, so just give me a second. Let me grab my calculator. Alright guys, so my calculator now, so 1620 multiplied by 100, that's going to be equal to the fact that t is equal to 1620 with 2 more zeros, divided by 12,000 multiplied by 4.5. That's going to give us 54,000. So 16,2,0,0,0, that's 162,000 divided by 54,000. Oops, too much zero, guys. Okay, and that should give us 3. Okay, so that works out exactly to be 3 years. So basically, the period of investment to which you are going to get $1,620 if you invest $12,000 at a rate of 4.5%, you're going to have to invest that money for approximately 3 years. Okay, so hopefully you guys got that one. Okay, we're going to move on now to question, well, we select question 1, we're going to move on to part C, and this is now we're going to be looking at ratio. Okay, so the sum of 3,500 is divided among Albert, Christine, and Raymond. Raymond received half the money. Albert received $437.50 and Christine received the remainder. You're to calculate part 1, Raymond's share, part 2, Christine's share, and part 3, you're to calculate the ratio in which the $3,500 was divided among the 3 persons, and part 4, the percentage of the total that Albert received. So we have our work cut out for us here, guys. Let's get right into it. Now, for me, I have a series of steps that I follow whenever I am working any particular ratio question, and this holds true for me. Some of the steps I may not necessarily need to do, right? But for consistency and for ensuring that you don't make any unfortunate errors, I stick to these 3 principles at all times. And so the first thing that I always do whenever I am doing any ratio question is that I always write down my comparative quantities. Okay, who or what I am comparing in the ratio. And so clearly you can see that I am sharing a certain amount of money between 3 people, Albert, Christine, and Raymond. So what I'll do is that I'll go across here. Let me just get some space here, guys. So the first thing I'll do, guys, is that I will always write down let's say Christine compared to Raymond. Was that the case? Let's check again, guys. It is Albert to Christine to Raymond. Okay, so let's do that better. It's Albert compared to Christine compared to Raymond. Let's put Ray for short. Okay, guys. Alright, so now that I've written down the comparative quantities, what I'd usually do next is that I would write down their individual shares. In this particular question, though, I do not have their individual shares. In fact, in part 3, they're actually asking us to find that out. So I don't have the shares to which they both got, but I have something even better. What I have is that you're telling me what they got. They're telling me here that Albert Albert, Christine, and Raymond received half the money. So Ray would have received 50% of the money, or half. Pardon me, guys. So Ray would have gotten half multiplied by 3,500, and that should pretty much work out to be 1,750. Okay, so we've gotten that part. Let's continue here. Albert received 437.50, so we know exactly the amount of money that Albert received. And obviously Christine received the remainder. So Christine would have obviously received 3,500 minus what we already know. So 3,500 minus 1,750 that Ray got, plus the 437.50 that Albert got. So if we're to go on our calculating device here, 1,750 plus 437.50 together Ray and Albert would have gotten $2,187.50. So to know what Christine got, we would have obviously had to subtract that number there. So 3,500 minus 2,187.50, and that will tell me that who am I looking for here? Christine would have obviously gotten $1,312.50. Okay, that's basically kind of like the idea that we have to start off with when we want to know what the amount of money that each person got. Okay, now I really haven't looked at the question as yet, really, because here I'm literally just reading the information and analyzing as I go along. So let me just look at the question now. It says that we are to look at Raymond's share, and we already found Raymond's share in our analysis of the question. If we go across and look here, pardon me guys, hold on just a second. So in our analysis, we already worked out by just reading and analyzing, we automatically found part one, which is Raymond's share. Raymond's share is half the money, so that's 1,750. Let's give that a tick here. Okay, and let's see what else we were asked to find. We were asked to find Christine's share. So Christine's share obviously would have been this part all the way down here. Okay, that would have to be the calculation for Christine's share, so let's give that a tick. And then now we're at part 3, where we're required to find the ratio. Now, normally whenever you're given a ratio question at the CSEC level, guys, and like I said, it's just usually you're given the ratio and you're asked to find the total amount. Now you're being given the total amount, or the amount that each person received, and you're now being asked to find the ratio. Now, we're working with some decimals here, guys. Definitely, we're working with some decimals. And if this was like whole numbers, like say, okay, so like this is 1,750. If this was like, say, for example, $440, and this would have been like $1,350, it would have been easy to cancel out. But the way that I'm going to show you how to do this here is that we're going to convert each of these money that each person received into a percentage, and then we're going to cancel it out. Okay, so percentages will give us whole numbers. Let me demonstrate what I'm talking about here. So we're going to try to find out what percentage did Ray got. So Ray would have gotten, okay, let's check this out. So Ray would have gotten 1,750 out of a total of 3,500, and we're going to multiply that by 100. So that should give us 50%. Okay, that's very easy because we already knew that Ray got half the money, and half of 100 is 50%. So we would have already known that Ray got 50%. Let's now look at Albert. Okay, so Albert would have gotten, let's see here, 437.50 over 100. No, sorry, not over 100, but over 3,500 multiplied by 100. I'm gonna have to go on the calculator for that one. So that's 437.50 divided by 3,500. Hope you guys are working with me here and you have your devices out. That should give us 12.5%. Okay, and that's still a decimal. So what we want to do is perhaps maybe just let's keep it at 12.5% for now. And then what we're going to do is just look at Christine's share. Okay, so Christine would have gotten also here 1,312.50 divided by 100. Again, why do I keep saying divided by 100? Divided by 3,500. I'm going to times that by 100. Okay, so clearly you see that she got 37.5% just by adding the 50 and the 12.5. That would have been 62.5. Subtracted that from 100, you're going to get 37.5. But just to confirm, let's go on the calculator. 1,312.50 divided by 3,500 multiplied by 100. Clearly that's 37.5%. Okay, so again we're working with some decimals here, guys. So we know, let's write down the ratio. Albert came first, so Albert would have gotten 12.5% compared to, so this is 12.5 compared to let's see here, Christine got the 37.5. To write a little bit smaller, guys. So 12.5 compared to 37.5 compared to 50%. And so we're still working with decimals, and it's a little bit hard to divide by a decimal, honestly, using a calculator. So since I have the option, what I could do is just kind of multiply everybody here by 10. What that will do for me, once I multiply everybody here by 10, that will automatically have me turning everybody here into a whole number. So if I multiply this by 10, 12.5 times 10, I'm going to get 125. I'm going to multiply this by 10, I'm going to get 375. And if I multiply this by 10, I'm going to get 500. So now what I have now is all whole numbers. I have a ratio. I have the ratio of the persons, I have the ratio of the amount of money that the persons receive in terms of percentages. And so if I cancel this down, then I would literally get a decent ratio here. So I can start with 5. 5 goes into this. And let's see here. Can 125? I think we could use 125. 125. Yeah, we could. 125 goes into itself one time. 125 goes into this 3 times, and 125 goes into this 4 times. So that's easy. Yeah, we could use 5, we could use 10. I don't want to use 10 because I would have actually gotten a decimal again, because I had initially multiplied by 10 to get the whole number. So dividing back by 10 would literally be reversing what I just did. So I'd have to use a different number other than 10. So I chose to use 5, or clearly 125 is a divisible factor by 125, 375, and 500. So my ratio boils down to being 1 to 3 to 4. Okay, so that was a little tough for perhaps most of you guys if you're not used to doing reverse ratio questions, but hopefully that explanation was of some aid to you. Okay, so we're gonna get right into the next question. Alright guys, so we're going to move on to question 2 here, and now we're working a PEMDAS question. Alright, I should be able to take this up here. Alright, I should be able to take this up here and bring it across to the next page. It's a lot easier for me. I got you guys. Alright, so hopefully you guys got that. Let's just create some space here now. Okay. right, here we go now, guys. So I'm just gonna just paste this right here. All right, let's zoom it up a little bit for you. Gotcha. Oops, too much. Got it out here. Perfect. There we go. So we're gonna be working this PEMDAS question, and so we have a couple of parentheses here that we're gonna have to work with. And these couple of parentheses here is that we have a set of numerical expressions to work out in here first before we work the ones on the outside. So I'm thinking that, okay, so let's break it down. Here we have an exponent to work out. So we have an E here. Then we have a D here. Then we have an S here. Okay, so according to PEMDAS, alright guys, so we're just going to go on to now question 2 here, where we have this PEMDAS question, and there are a couple of areas that we are going to have to work out first before we work out the outer brackets. We have inner brackets here. We have an inner bracket here, which is the exponent part. So let's label that. This is our E section. Okay. Then after working out the E section here, all right, we're going to have to work out the D section, which is the division. Then we're going to have to do the subtraction. And then that should take care of our inner brackets. Then we're just going to proceed to the outer bracket, which is to add the 3. And then finally we're just going to be adding the 1 here. All right, so we're going to be working it in stages. Remember that we're working with the principle of P, E, M, D, A, S. Okay, we know that we're working with the parentheses first, so we're working what is inside the inner parentheses. Then we're moving on to the exponents. There are no multiplication, followed by division, followed by addition, then subtraction. So we're working with this order of operation here. So I'm going to do it in stages. -4 squared. Okay, what a lot of you guys, or what a lot of students, what I see a lot of students do is that they tend to insert -4 on the calculator, then they hit the square button and it tells them it's -16. And so it's going to tell them it's -16 because when you insert -4 on the calculator, then the calculator interprets -4 squared as being squaring the 4, but it's not squaring the negative. So you have one of two choices. If you're going to be using your calculator, you can insert the brackets and then insert the square function. It should tell you that the answer is 16, or you're just going to have to automatically know that whenever you square a negative number, you're going to get a positive result. Okay, so this right here is going to be 16. Okay, we're going to put the subtract 7 here, 14 divide, and put that bracket in a bracket plus 1, and outer bracket 3 plus here. Okay, so all we did basically is that we just worked out this part of the problem. We still have the inner brackets to work out, guys. Okay, so we're gonna have to divide next. So the E is now gone. We're gonna have to divide next. This is gonna be outer bracket 3 plus inner bracket 14 divided by 7 is 2, subtract 16, close the inner bracket, close the outer bracket plus 1. Okay, all right, so the problem has been drastically reduced almost down to nothing. So we have the outer bracket here, 3 plus inner bracket 2 subtract 16 is -14. Okay, and so that's the inner bracket, outer bracket plus 1. Okay, and finally, when a negative clashes with a positive, the result is a negative. So we have outer bracket 3 minus 14, outer bracket plus 1. Okay, nice. 3 minus 14, that's -11, plus 1, -11 plus 1. We take the smaller from the larger. We take the smaller value from the larger value and keep the sign of the larger value. Okay, so now we have -10. So that wasn't too bad at all, guys. That was pretty easy. Okay, so hopefully you guys got that. Remember, whenever you get problems like these, guys, you're always going to be working with the principle of PEMDAS, which is the order of operations. Remember that we work according to the order listed here, with the exception of the multiplication and the division and the addition or subtraction. There is an or. So whichever one of those operations appear from left to right first, then that's the one you're going to do first. But there are videos on my channel that explicitly explain how it is that we work with the order of PEMDAS. Very powerful tool when it comes to working basic arithmetic problems. Okay, beautiful. So hopefully you guys got that one. And we're gonna be moving on next to the part 2b here, which is substitution. All right, so I think I also should be able to pick this up here and bring it across to the next page. I think I'm gonna have to create some space here, guys. So let's, hopefully you guys got that. Let's just create some space here. Let's put it right here. Gotcha. All right, so the problem that we have here is that we are given an expression. We are given that x is equal to ut plus half at squared. It's a very famous formula. All right, and I believe this is the formula that we use to find distance when we're doing physics. We use it to find distance when we're given the initial velocity, the acceleration, and the time. I believe this is what we use to find distance. Famous formula. Nevertheless, the point is that we're going to be doing some basic substitution here in this formula. So we are required to find what is the value of x when we are told that u is 3, t is 5, and a is 4. So we go ahead and replace those letters with those numbers. So x is then going to be equal to, x is going to be equal to ut. Ut means u times t. So u is 3 and t is 5. And then we're going to be adding half the value of a times the value of t squared. So half the value of a is 4 times the value of t is 5, so that's 5 squared. Okay, all right, so x is equal to 3 times 5 is 15, plus we're going to find half of 4 times 5 squared, so that's 4 times. We're going to have to square first. Remember laws of PEMDAS. Okay, so square 5, going to get 25. Then we're going to do all multiplications. This is x is equal to 15 plus half of 4 times 25. You have a choice. You can say half of 4, 2 times 25, 50. Or 4 times 25 is 100. Half of 100 is again 50. Half of 25 is 12.5. 12.5 times 4 is 50. So either way, the answer is going to be 50. Okay. Multiplication is commutative. So the order in which you multiply does not change your result. Okay. All right. So this works out to be 65. Very easy. Okay. It's not that challenging at all. So very good, guys. Very good there. Let's get into the next question. Okay. And at the bottom here, let's see, we should be able to pick this up. Oops, it's another type of substitution. Let's cut and paste here, guys. Gotcha. All right, so let's just erase this and place this right here. Move it over like that. Gotcha. Beautiful. So we're gonna move this down here. Beautiful. So hope you guys got that working out here. Feel free to just kind of replay the solutions that we had to get a better understanding. So now we're given this binary operation. This is another variation for substitution. So we're told that p and q are connected by the operation p cubed minus 2pq plus q squared. And we are asked to find the value of 3 connected with 2 via this operation. We say p operation q and we say 3 operation 2. These symbols, well, you can have different symbols. Most of the time you're going to see an asterisk or a little circle, like a little degree sign. And then sometimes you might see triangles or rectangles, but the symbol that is being used is just to show you that the two letters are connected via via multiple operations or combinations of operations, and the combination of operations to which they are connected by is this expression over here, p cubed minus 2p cubed plus q squared. So we're going to have to try to find out what is 3 operation 2. So by comparison, p is 3 and q is 2. P is 3, p is the first letter, 3 is the first number, q is the second letter, q is the second letter, 2 is the second number. So p is 3, q is 2. Let's do our substitution. So p is 3, so that's 3 cubed. Okay, minus 2 multiplied by p cubed. So p again is 3 times q is 2 minus, well, actually it's plus here, q squared. So 2 q is 2, so that's 2 squared. Okay, easy substitution. 3 cubes is 27, so that's 3 times 3 times 3, minus 2 times 3 is 6, 6 times 2 is 12, and of course 2 squared is 4. All right, so 27 minus 12 is 15. Yes, we are correct, 15, and 15 plus 4 is equal to 19. Okay, hopefully you guys got that. That was not too challenging at all. Okay, so we are actually finished with question 2. Let's double check to see if there's any more questions at the bottom. That's it, guys. That is it for questions 1 and 2. We're going to move on now to question 3I and continue all the way down to question 4. We're going to be doing some algebra here, some substitution, some transposition, and some direct, indirect proportion and percentages. Okay, so let's see how this part goes. I'm just going to be posting this video as a part 1, and then I'm just going to jump into part 2. Okay, all right, see you guys in the next video. Bye.